Hello, my name is Paul Bontempo. I'm joined by Nicholas Derby, and this is our presentation of our GeoGuessrNet project for geolocation of Google Street View images using neural nets.
So, primary motivations behind our research. The main task that we're looking at with our research is geolocation, which is just identifying the location of an image. But this task comes with various current limitations. So a lot of automated systems that seek to perform geolocation have an over-reliance on feature engineering or complex algorithmic approaches which fail to capture a lot of the higher level visual patterns for differentiation. And then a lot of the relevant data sets for geolocation are significantly imbalanced in terms of their classes. There's a lot of representation for countries in Europe, North America, and East Asia, but little representation elsewhere. And then some existing research focuses on maybe city level or landmark recognition, but our main contribution is looking at country level categorization.
So the prior work in this area is often either too computationally expensive with complicated models or is very location specific with its data set, and our work seeks to bridge these gaps by expanding location coverage globally but investigating a hybrid architecture with minimal parameters. So a lot of the previous work focuses on like modified feed-forward architectures like EfficientNet v2, which is a convolutional neural network where there are convolutional and pooling layers in between the feed-forward layers to capture information from the input image. Or on the opposite end, we have vision transformers, which are more complicated transformer models for vision data, which use attention heads and an encoder or sometimes encoder-decoder model, which are often very parameter heavy. And so the previous work by Suresh et al. Used an convolutional network model, but was focused only on the United States, and we want to expand globally, whereas Haas et al. Used a very complex and high-performance transformer model for global prediction on the GeoGuessr set, but we want to achieve similar results with a simpler model.
So we can break our approach into kind of two basic experiments. The first experiment is testing the baseline performance of existing state-of-the-art vision transformer and convolutional or CNN models on our GeoGuessr dataset. So we will simply fine-tune the existing models on our dataset and see how well they perform without any additional modification. Our second experiment seeks to combine the elements of these two architectures to hopefully create a more optimized model for this task. So that could include combining convolutional layers with an attention-based vision transformer model. It could also include developing some sort of hierarchical classification scheme. So the model might identify the more general region or continent of an image before further classifying it based on country. So these are just a couple sort of reach goals that we hope to implement in the coming days.
So a quick overview of the dataset that we're using. We found it on Kaggle, and it's composed of approximately 50,000 panoramic images, which were pulled from the GeoGuessr online game, and those images themselves come from the Google Earth landscape documentation project. And the images from the dataset are divided initially into 124 classes based on their country of origin, as you can see here. But in our pre-processing, we remove any classes with fewer than 20 images to get a final total of 87 classes for our gold labeled data on which we fine-tune these models.
So we do have results for experiment 1, and this is after fine-tuning both of these models on a training data set composed of about 40,000 of the images in our overall data set. And so the models that we chose were EfficientNet v2, which is a CNN-based model, as well as a Google Vision Transformer model. And as you can see, just looking at the metrics, they performed about the same. EfficientNet did marginally better, but not significantly. And just to give you an idea of what these metrics mean, top 1 accuracy refers to just looking at the top class identified by each model and comparing that to the gold label class, whereas top 5 looks at the 5 most likely classes identified by the model. And as you expect, that accuracy would increase. But overall, these performed about the same, and we hope to get better results with experiment 2.